For the situation that we have in this problem, we're asked to look at the state of stress that's on the skin of this aircraft wing. The skin is basically in the plane. So what we have is a set of components of stress, sigma y, let's say, and sigma x. Like this. The point being is that we do not have a component of sigma z. We also have some shear stresses here of tau xy, but we're just going to focus on the relationship between the normal components of stress and strain. And what we want to do is show that the relationships that we have shown up here are valid for relating epsilon x, epsilon y back to sigma x and sigma y. So from our basic equations that we derived in class, epsilon x is 1 over e sigma x minus nu times the sum of sigma y plus sigma z. We have epsilon y is equal to 1 over e sigma y minus nu sigma x plus sigma z. So these two relationships are true in general. I guess there's actually a third one that I can write down, but I don't need that. We weren't really asked to deal with it. But if we had been, then we would have this third equation. The point being, though, for these first two, we're given that it's a state of plane stress. So therefore, if I take these first two equations, I can write these as sigma x minus nu times sigma y is equal to the Young's modulus E times the strain there of epsilon x. The second equation says that I have minus nu sigma x plus sigma y is equal to E times the strain in y. So this is equation 1, this is equation 2. I'm going to do two things. I'm going to multiply 1 by nu and add to 2. The reason for this allows me to get rid of the appearance of sigma x. Okay, so that's going to be, I'll write it out in detail here, nu times sigma x minus nu squared sigma y minus nu sigma x plus sigma y is equal to E 1 plus nu, oops, that's not correct, is I'm trying to work too fast here, epsilon x times nu plus epsilon y. Again, the reason for doing this is I'm able to cancel out this, and from this I am able to solve for sigma y, where sigma y therefore becomes E divided by 1 minus nu squared times the quantity there of nu epsilon x plus epsilon y. So that's the first equation. Second equation, we do somewhat the same thing, but a slightly different step here. I want to get rid of sigma y, so what I do is I multiply equation 2 by nu, and I add to 1. So in that case, what I have here is sigma x minus nu squared sigma x. I have minus nu sigma y plus nu sigma y. And so on the right hand side, what I have is E epsilon x plus E nu epsilon y. Of course, these cancel out. I'm able to end up with sigma x then is equal to E divided by 1 minus nu squared times epsilon x plus nu epsilon y. Effectively, what we're doing here is we are generally given these equations, which basically say give me the state of stress and I can calculate the strain. We inverted those relationships such that for this equation and this one here, for a state of plane stress, give me the strains, I can calculate the stress. So it's really just inverting those two plane stress equations.